So I would like to talk about how to describe chemical reactions. So which observations we could be able to make with in different equations. So it's really important to notice state symbols and then to be familiar with the colors of compounds. But this is nothing new. It's just a different perspective on how you see chemical reactions. And now I'm going to write it 3 different reactions, and then we're going to discuss the observations that you could make and how those could be useful. So here we have a list of reactions. We're going to look at each of them and discuss the observations that can be done, okay? Because those are all reactions that you will come across through the years of chemistry. So it could be from GCSE to A level. It's important to be confident in noticing the hints that you have in an equation to describe the observations and also the appropriate way to do it. So I'm going to look at the first one now. We have ethanoic acid reacting with sodium hydroxide. So we have a neutralization reaction, formation of a salt, and formation of water. In this case, you can notice that there is no change in physical state, which means that there is not really observation that we can make. Okay, in fact, if the physical state don't change, unless there is a color, there is no observation. So we won't see this reaction happening. Okay, so for example, this is just a neutralization reaction, nothing happens, we can't see it. There could be a change in pH, but that is not going to be an observation because observation is something that you can visually see. Okay, just from the reaction taking place without taking any extra measurement. Okay, difference is the second reaction where we have again an acid, but this time we have a carbonate. And the carbonate, in fact, is always used as a test because it releases carbon dioxide. The observation is not that, so you can't describe it as carbon dioxide because then you can like, okay, how do you see carbon dioxide? But it's the fact that it's a gas in a solution. Okay, so this is observed as effervescence. Okay, and it's effervescence because we have a solid. Okay, so always think about the like vitamin tablet that you put in water and it starts to fizz. That's the observation. When we have a solid and a gas is produced at the same time, this is the observation. It's effervescence. Okay, if it's just a gas formed out of a solution, you would see bubbles, like if it's sparkling water. But if you have a solid, then you would have effervescence. Okay. Similar observation is for group 1 metals with water. A solid in a liquid that would form a gas. Again, we would describe this as effervescence. Of course, because we have a solid and there is no solid as a product, the other observation would be the solid is getting smaller, or it's floating on the surface and moving because the gas makes it move, or the solid disappears. Okay, so anything that relates to the solid or the fact that there is no more solid at the end. Okay. So those are the observations. Useful because for the acid, this is a very distinctive reaction of an acid, which means that we can identify it could be a test for acid. But if you think about it, could be a test for carbonates as well. Because if you have carbon dioxide produced, then you could test for carbon dioxide by using lime water. So this would tell you that it's not just like is not just a metal reacting with an acid, because that would also release a gas, like in this reaction, but it's actually a carbonate because carbon dioxide is released. So notice how we have so many tests, that can be used for this, like the same reaction can be used for different tests. Okay, and this is useful as an observation because it could help us identifying the group 1 metal or describing or analyzing the difference in reactivity of group 1 metals, because as we go down the group, the reaction becomes more vigorous. Yes, so more gas will be released. We would observe more bubbles, or well, to be specific for these group 1 metals, is that is an exothermic reaction, so the gas would actually ignite. Yeah, so it would be a small explosion. Potassium would be lilac. So then we can go into more details about each metal. But that's a general thing about this reaction, and something that you can always observe, or you can always describe, because most of the time you have the reaction down, or you need to know the physical state. Okay. The other observation involves changes in color, typical for group 7, and we're talking about displacement reactions, but you will see it a lot in year 13 when we look at ligand substitution reactions in transition metals. Very often we could have a change in physical state or just a change in color. Okay, and here you need to be familiar with the colors of some elements. So group 7 elements, they have specific colors. So bromine is like brown, chlorine is like green, then depends on which solvent they are. But we would observe it, because notice that there is no physical change, there is no change in state, but there is a change in element present. If the element has a color, that would be the change and the description that you would have to do. Okay. And the last reaction that we can observe and discuss observation is a precipitation reaction. So this is, by the way, a reaction that you need to know now for tests for halogens or for tests of haloalkanes, because it's Tollens reagent, also called the silver mirror test. And in this case, we have a solution because they're ions. So if they're present as ions, they're going to be aqueous solutions. So silver solution doesn't have any color. Fluorine ion doesn't have any color. So remember, halogens, they have a color only if they are in their elemental state. When they reacted, they would form an insoluble compound. This is a precipitation reaction. So what can you observe? A precipitate. And sometimes the precipitate has a specific color. In the case of halogens, remember, chlorine is the white one. If it was silver bromide, it's cream. Silver iodide is yellow. So there could be different colors. For transition metals, this would be the same case. If you have a precipitate, the precipitate would probably have a different color than another compound, because transition metals, they are particular in terms of their colors. Okay, so this is a nice summary of all of the observation that you need to be familiar with and applied it to so many different topics. Okay, so I hope it clarifies it, and yeah, I think that's a nice summary of it.